Hello guys, here Mr. G with another video. Now after we've done a series of videos on acid and bases, we are ready to start answering some question and practice. And there is everything that we need to know for the exams. Okay, this time we're going to be answering question 1 from the informal test on acid and bases. This is a multiple choice. It's a very fast video. It's going to be only question 1 and we'll see. This one is a multiple choice. Please, before we carry on, subscribe for the channel so you can get all the notification and videos I post on regular basis. Question 1 is a multiple choice. You choose which one is the correct answer. Question 1.1, the pure water is neutral at 25 degrees because the concentration of H3O plus is equal to the concentration of OH minus. That is the answer. There's nothing to say. If the substance is neutral, it's because the concentration of OH and H3 plus is equal, or they are equal. So the correct answer is A for this question. Question 1.2. Please guys, stop the video, try to answer the question. Which one of the following is true if the acidity of the solution increases? Now remember the pH scale. Let's write it here, pH, while you start answering. pH scale is going from 1 to 14. This is a 14, right? It's going from 1 to 14. You also remember that near the 1 or 0 is going to be the acid. Let's fix this one. It's not 1, it's a 0, from 0 to 14. And here is a basis. Okay, this is just a little recall. Okay, now bases will have OH or produce OH minus. It means that the concentration as from 7, also remember in the middle is 7 and is neutral. Okay, now here the concentration of OH as from 7 is going to increase. This one is going to increase. We're going to do it with an arrow. There we go. And in this case, the concentration of H3O plus will increase, okay, closer to 0 to be acid. So now here it's very simple. The pH, what is going to happen to be an acidity? Remember, we're talking about acidity. The concentration of the H3O plus must increase. So the options are either A or B. But the pH must go towards 0. And therefore it's going to be decreases. The answer is a B. Very simple question. It's a good question, this one. Question 1.3. Which one of the following salt will lower the pH of distilled water when it is added to the water? And this is a very good question, guys. This is hydrolysis. Okay, so now remember we did all this one in a video. We'll post the link so you can go and watch the video on hydrolysis. Okay, but remember the type of salt is coming from the reaction of the acid and base, certain acids and bases. For instance, sodium chloride is coming from the combination of a sodium hydroxide and hydrochloric acid. There is nothing to say that this one is a strong base plus strong acid. Alright, that will give you that salt. And you remember that salt. So now this salt here react with water. So NaCl, let's just do this, Cl react with water, or let's say dissociates in water, Cl, to form Na plus Cl minus. But this ion of a strong acid and strong bases do not go hydrolysis, so A cannot be the answer. Now note the following before we carry on. We're looking for one of them that lowers the pH, okay? So one that is going to increase the concentration of H3O plus in the solution. All right, So now this second one, B for instance, is sodium carbonate, is a strong base, which is sodium hydroxide, and a weak acid, which is in this case hydrogen carbonate. Weak acid. So now the sodium carbonate dissociates in water. Guys, I highly recommend you to go and watch the video on hydrolysis because it could be tricky. So the sodium carbonate Na2 CO3 dissociates in water and break into ions that are Na+. Remember, ions of strong bases do not undergo hydrolysis. So this one does not go hydrolysis and dissociate in CO3 2+. This is what happened. You will have two ions of this one. Okay. Now, what is happening? This substance further react with water. So let's look at this reaction. CO3 2+ react with water now. H3 H2O, H3 is water. H2O liquid. Okay. And now here is where things come. What is going to happen here? The water is going to give one hydrogen to the CO3 2+, and you will have H CO3 1+ plus OH minus. What is happening here? The concentration of OH is negative. That is why it will actually level up the pH. So B is also not the option. But guys, this one is the idea. I recommend you to do with C. You will see C also does the same as B. And let's go quickly do D. You know what? Let's see C again, because C is tricky. So C is CH3, CH3, COO, and A. Same story. This one is coming from ethanoic acid, which is a weak acid and strong base. Okay, so this reaction here, or this salt, is coming from the production of a weak acid and strong base. Once more, guys, all this one is in the video. So when CH3 COONA dissociates in water, H3O, my goodness grace, is H2O. Dissociates in water, you have CH3 COO minus, and you will have Na+. Na+ is an ion of a strong base, so it does not undergo hydrolysis. But the CH3COO go further and react with water. CH3 COO minus plus H2O. This is the hydrolysis, guys. This part, when that specific ion now react with water. Okay, so this one will give you, once more, this water is going to give one proton to the CH3COO, and then you will have CH3 COO H plus OH minus. And then you can see that the concentration of OH is increasing. So the final one is D. And now D, we have NH4, NH4OH. Okay, so what is happening with NH4OH here? NH4OH is going to be broken into NH4 plus, when it's dissociated in water, and OH minus. The NH4 reacts further with the water. Okay, so it's NH4 plus plus water. Okay? And one proton is going to be transferred from the NH4 to the water to produce NH3 plus H3O plus. You can see that the concentration of H3O plus is increased. As you can see, therefore, what is going to happen? The pH is going to get lower. And the answer, therefore, guys, is D. This is a very good question because it's about hydrolysis. And hydrolysis, let me tell you, is a little bit tricky. Now, question 1.4. A 1 mole per decimeter cubic solution of each of a number of acidic is prepared. Which solution will have the lowest pH? And this one is a very good question as well. This one is a very good question as well. All of them have the same concentration. That is important to know. Each of them will have the same concentration. Which of the solution will have the lowest pH? Guys, the answer for this one is H2SO4. Now, why? Because when H2SO4 dissociates in water, will produce double the amount of ions. As you can see here, the ratio of the concentration of the acid to the concentration of the amount of ion produced is 1:2. So the concentration in actual fact of the ion will be increased, and therefore that one will decrease the pH. It is B the answer. It is a good question, that one, because you need this one to calculate pH a lot. Okay? Question 1.5. Which one of the following represent the product formed during the hydrolysis of NH4 plus? And we already do that, but we can go there and say NH4 plus, and this one hydrolysis will go to H2O plus H2O. What is going to be doing here? We did this one right now in the previous question. So now this one reacting with water will be NH3 plus H3O plus. Which one is the correct answer there? The correct answer is C. There we go. And question 1.6, which is the final one, when 10 cubic centimeter of nitric acid is added to 990 centimeter cubic of pure water, which one of the following statement is true? And then they give you options there. The concentration of OH remains constant, and not possible. The concentration of H3O plus remains constant. The Kw increases, and the product of the concentration of H3O plus OH remains constant. That one is the answer. And that one, in other words, is Kw, which stays constant. Guys, this is question 1. I hope it helped. Next time we're going to go to another question. Question 2 was already answered in a previous video. We are going to probably go to question 3 next time. Thank you for watching. I'll see you next time. Mr. G here.